Okay, so we just covered strings. Another type of sequence that's what you might classically think of a sequence is a list. So lists are mutable sequences of anything. We'll learn what that means in a second. Mutable means they can be changed. So we can have a list of integers here. This is actually the Fibonacci sequence, but it could be anything. It's just a list of integers. We can then have another list that has integers, strings, booleans, and other lists in it. We could have any combination of these things. They're all valid as lists. So we can then slice the list so we can get the first 3 elements of the list, or we can get just a single element of a list. So this would be the actually the 5th element of list M. So in Python, we always start indexing from 0 for a couple different reasons. So this would be 0, 1, 2, 3, 4. So the 4th element of list M is this Boolean value true. We can then mute, or we can change the list by saying, okay, we want to make that 4th value false. And then if we could go back and execute this cell, we would see that it's false. And if we then look at from item 4 to the end, we'll see that we're getting these 2 items, and it's false, and then this other one. This is a little complicated. We will go through all this in more detail in the next week or 2. Question?
So I just saw the error from 0 to 3.
Yeah.
So it should output like 4 numbers.
Actually, no. In Python, you have. Let me show you.
That's just because of what you said earlier, where it's up to not including.
Exactly.
So if you get 0 to 3, you're getting.
Yeah. So the way the indexing works, if I just write the indexes below here, this is 0, 1, 2, 3, 4, 5, 6. And if I then write L 0 to 3, this is going to give me starting at 0 and then up to but not including 3. So it's going to give me this would be the first element. So I get element 0, I get element 0, element 1, element 2, but not element 3. It has to do with the way that there's a number of reasons why this comes in handy later. At first it seems strange, but you just have to memorize that when you give a range, you get the first element, you get this element, but you don't get this one. You just get the one before it. Yeah. It comes in handy, but we'll cover all that soon. Tuples are like lists, except they're not mutable. You can't change them. So if we create this list, this tuple of 3 integers, you can index it the same way, but if we try to store a value to an element of that tuple, it says the tuple object does not support item assignment. There are reasons where you would want a tuple and not a list. If you know up front that you're not going to want to change this thing, it's more for indexing or something else, you would not want to have a mutable type. Yeah.
So is the difference between the list and the tuple using parentheses versus the?
Yeah,
okay.
That's the other. So the way that the computer knows that it's a tuple and not a list is that you're using parentheses instead of brackets, instead of square brackets. There's also something called an array, which is a NumPy version of a list that has a lot more features, and just quickly we'll go through this. So one way we can start is just with a list, and then display it as an array. So what I did was I made a list, and then I just typed MP, which is the shorthand we used for NumPy. If I just, you don't have to scroll up, but I'll just show you. We did import NumPy as NP, and what that did was when we write the letters NP, it knows that we're talking about NumPy. So when I say np.array, that's numpy.array, so that's a function of NumPy called array, and the argument or the input to that function is this list that we made, and the output is this array. So we're going to just look at a few different functions. So NumPy has the ability to output an array of zeros, which can be handy, or a range of integers from 0 up to, in this case, we just give it one argument. It gives us 0 up through, but not including that number. So an array of integers that's 5 long. We can also give it a start and an end. Again, it doesn't print the last value. We can have a different increment. We can equally span a range, in this case from 0 to 10 with 5 values. This would give us floats from 0 to 10. We can use random numbers. We can have an array of random numbers. A lot of things you can do with NumPy. Going back to the core data types of Python, this doesn't require any other packages. There are sets. Sets are unordered collections of unique objects. So this is, if you're familiar with set theory at all, this is what it's doing. So we can make a set that has the letters A, B, and C, and another set that has the letters A, D, and E. And if we type AND, this will give us the union of, or rather the intersection of those sets. So this would be all of the elements of set 1 that are also elements of set 2. So that's just this letter A. If we type this bar, this is the union. So this is all of the elements that are elements of set 1 and anything that's an element of set 2. So this gives us A, B, C, D, and E. We can convert lists to sets. So these L and M, remember, are the lists we had from before. So if I just show you, don't worry about this. I just inserted a cell to show you this. So what I'm doing here is just showing you what I stored now as S3 and S4, these two sets. I can then take the intersection of those two, or the union, and again you can see that both those have 2 and 5 in them, so the intersection is 2 and 5, and the union is all of those elements. And
for the M, we have a bunch of other stuff in there, right?
we did.
Take the numbers.
We did. So I just sliced out the first two elements. Yep. Good call. And then we can also get the difference of these two sets. So I can take set 3 and remove all the elements that are found in set 4. That's sets. And then the last data type to just briefly cover in this crash course is dictionaries, also called dicts, or hash tables, where a key points to a value. So one way to enter a dictionary is using, so first of all, we have these curly brackets that tells it it's a dictionary. And then we have the key, which is here a string called name, and the value is another string, which is the person's name. We then have another key called age and a value called this integer, and another key called DOB, and the value would be the string for the date of birth. So when we store that dictionary, we can view the whole dictionary like this. This is how it's stored here. and then to use this, we can use the square brackets, but it takes, instead of a number, it takes the key. So the key is name, and the value is John Doe. Another thing you'll notice is that the order in which they're stored in the dictionary, they're not in order. This is important because if you tried to go through all of the key value pairs one at a time, you might expect them to be the same order that you typed them when you type, but Python doesn't care what order you type them in. So that saves computational time, but it also there's a way to do it. There's something called an ordered dictionary, and here's the zip code, and then again there's the value. So one other thing, there are these various loops and control structures you can use. So we can say we're going to store x as 5, and then we're going to say is x less than 6? It should be true. And is x greater than 4? That should be true. So and then we do and, combining them, that statement is also true. I'm going to say is x not equal to 4? That's true. We also have this function called in, so we can say is 5 an element of this list? Is 5 in this list? It's true. Is ELL in this list of characters, which is also known as a string? It's treated very similarly to a list, and it's true. So this substring is part of this string. And then we can ask, is the length of this word greater than or equal to 5? It's also true. So these tests, or these comparisons come in handy in writing programs. So here we can do we can look at these tests called if tests, or else if, or else. So here we say, is D in this string ABC? If yes, it will say learn your alphabet, because that's not true. It says then else if, so if this is not true, then let's look at this. Is 2 plus 2 equivalent to 5? And it will say sometimes yes, but of course that's not true either, so it won't print this. Finally it says else print nothing is true. So when we execute this, that's the only output we're going to get. If I had changed this to C, we would get this line and then not do the rest. Or if I changed this to 4, I would get this being true. But as written, it will go through and evaluate each expression until it gets to the last one and just prints whatever is after this else statement. There's also while loops. So we can say while this expression is true, I'm going to execute what's in this block of code. So I'm going to set I as 0. While I is less than 5, I'm going to print the value of I and add 1 to it. So it's going to print 0, 1, 2, 3, 4. Each time it's going to add 1 more. But it then gets to 5, and then it says, is 5 less than 5? Well, no, so then it exits. And we can see that I is indeed now 5. Last thing here is a for loop. These are also really useful. So we can say for x in this list, I'm going to print x squared. So I'm going to, for each element, I'm going to print 0 squared, and then 1 squared, and then 2 squared, all the way up to the end of the list. That's a for loop. Finally, we installed a bunch of packages today, and when you're running a notebook, you might want to know what version you're running. So we can import this built-in package called sys and type sys.version, and this will give us the version of Python that we're running and where it came from. There's also this package called platform, which gives us some slightly different information. So within platform, we can print Python version, or we can print the platform version, which should be like a Mac OS, which is called Darwin, or some version of Linux. Finally, there's this thing called version information. So to do this, this is a handy package. So what we can do is we can go back to our home, open up a new terminal, and we're going to type pip install version underscore information. And don't worry, my screen is acting weird because I made it bigger, but so once that's installed, we can go back and execute this cell, and it's going to print out this table with all the information about our Python version, our IPython version, our OS, the math package, which it just says was not found because it's a default package basically, NumPy, sys, again that's a default one, and platform. So and these are all packages that I listed here. So what we might want to do is look up or just note all of the packages that we had imported during this notebook. Typically you want to import them at the very beginning so they're all up at the front, so it's all very explicit. You can copy and paste those down here, and you could also do this at the beginning as well. But basically it's a nice way to document all of the packages that you used, and so someone looking at your code or your notebook can see which versions, and you can see also that, oh, maybe the reason it didn't work is because I had an older version of NumPy back then and now I'm using a different version or something. So when we're done with the notebook, you can close it. It might ask you if you want to leave because it has unsaved content, so you can say, oh, whoops, you're right, I should have saved. So you can stay on the page, and then actually it'll automatically save for you. You can also go all the way up to the top, or I've hidden these headers and toolbars. You can also click save here, and it'll save a checkpoint, which is it actually keeps when you hit that save button, it'll actually save the it'll actually make a checkpoint, so you can go back in time and have different versions. And then you can safely close the notebook. I can exit out of this terminal and close that window. I have another terminal here I can exit out of and close that window. And then I can close. If I want to, I can select this and say shut down, but you don't have to. But if you want to, if you have a lot of notebooks open, you can shut them down independently of each other. And then you could just close this window and then go back to your terminal, and you see that we've been saving this notebook here, we've been opening and closing terminals, and now finally we have this kernel shutdown. Everything's ready to be shut down. We just type Control-C, and it will say, do you really want to shut this down? You can type yes or just type Control-C again. It's not even shutting down any kernels at this point because we already did that, but if there were open, it would safely close those. And now you can see that our notebook here was just recently updated like a minute ago. Oops. So that's great. This is just the working version though. Of course, the original version is still on GitHub, so you could, if you deleted something or you wanted the original, you can always go back and download that again using curl or using the raw save as approach. And that's a lot for today, but that's the end. And we will be going back through pretty much everything that we covered today. We will be going back through in the next couple of lessons. So this is just a very quick overview of Jupyter and IPython and the notebooks, and then the core features of the Python language. So that's it for today.